Okay, so good morning everyone, and welcome you back to my YouTube channel. And presenting before you this tutorial is Bill Clayman. So last time when I was teaching you rate laws, I remember we covered how to write the rate law, and at the same time we also covered how to find the order of reaction, and we also learned how to find the overall order of reaction. So this time around we'll continue from integrated rate laws. So integrated rate laws, um, they simply show the relationship that is between reaction concentration and time. Okay, or let me say they show the relationship that is between the concentration of something or the rate of something with time. So you need to know the integrated rate law for a first order reaction. Okay, so for a first order, we know that rate is equal to constant K with the power 1 there. The concentration of A with the power 1, that is first order. So if we integrate it, okay, that is, I mean, we differentiate it, we find its differential form, then automatically it's going to appear like this formula that is in pink. A at some time is equal to A at some initial time, the natural log or exponent E to the power negative kt. So if you work out this, you integrate it, you do further integration, your answer is going to appear in this form. Okay, so it's going to be the natural log of the concentration of A at some time equal to negative kt, where k is the constant, uh, the, the rate constant, plus the natural log of A at some initial concentration. It's very simple. You just have to understand. So if a reaction is first order, a plot of limb A at some time versus T will yield a straight line. So of course, the line will be straight, like I explained in my previous video, but then the slope is going to be negative. It will be falling downward. Okay, so these are just first order processes. I think we covered this. Okay, so this is how you expect the line to be. It will be dropping, having a negative slope. So this simply shows you that this is a first order reaction. So in my next video, I'm going to illustrate to you simply how to find integrated rate laws using these formulas and how to find the half-life. Okay, so these are first order graphs. I'm sure you are able to see how this is coming out. Okay, so for the first one, if you use this formula, it will come out like this. It will be slanting a little bit, but with a negative slope. Even the one at the left is just the same. It will be slanting a little bit, so it will be slanting straight with a negative slope. We come to second order processes. So second order simply means that when you have rate equal to constant K, the concentration of A, you are going to power the concentration of A to the power 2. So if you do some differentiation, you arrive at this formula that you're able to see here. 1 over A at some time equal to negative kt plus 1 over A at some initial time, which is 0. But then if you check, this formula is able to hold in the form y is equal to mx plus b. That simply tells you that this formula is a straight line. It produces a positive slope. But then this negative simply tells you that in this form it will produce a negative slope. But we ignore the negative, so it will produce a positive slope. Okay, let me show you. So this is the formula, but you don't put a negative there. Okay, it must yield a positive. It must yield a straight line with a positive slope. Okay, so for first order, I'm sure you're able to see. For first order, it's gonna be a negative slope because the constant k has a negative. But for second order, we ignore that negative, and now it must always produce a positive slope. I'm sure we learned this, how to determine the reaction order. I taught this in my two previous videos. Okay, this is just one and the same. I'm sure you know by now. So for this one, you have been given the time, the concentration of nitrogen dioxide, and the natural log. You can plot this on the diagram. It can hold, or if you can't plot that, you can collect data from one row and place it into the integrated rate law. But if it doesn't fit, then it means that you need to plot the diagram and simply use a tangent. I'm sure you're able to see this plotted diagram here. If you draw a tangent, you're able to find the gradient. Okay, the gradient must tell you something. So these are very simple things. Okay, so for a second order process, that is how the graph comes out. Okay, that is how the graph comes out. It must come out straight with a positive slope. And of course, this is the formula. That is the formula. That is how it comes out. It's just 1 over a at some time equal to kt plus 1 over a at initial time. Now, this is a straight line. Therefore, the process is second order in nitrogen dioxide. So sometimes they'll give you a graph and ask you to plot. Then they'll ask you which one is the first order, which one is the second order. Okay? Which one is the first order, which one is the second order. So how can you know that this one is the first order and this one is the second order? First order produces a straight line which has a negative slope. First order. So the second order produces a straight line with a positive slope. Zero order produces a slope which is slightly slanting, but it is negative. The half-life. Half-life is defined as the time required for one half of a reactant to react. The average time taken for 1 over 2 of a reactant to simply react. Okay, so because the concentration of A at T is equal to 1 over 2 is 1/2 of the original A. So that simply tells you that the concentration of T is equal to 0.5 the concentration of A at some initial time. I'm sure you understand. You half-life, we saw about finding half of that molecular substance that you have been given at some time. Okay, reducing what you have been given by half. So don't mind my voice, please. Okay, so look at the diagram. You have pressure in dose from 37, 75, 150, and then this is the time 10,000, 10,000, 10,000. So they will ask you, saying, at 75, what was the half-life? So you can simply go at 75, then you hit the curve and take it down there. Or they can ask you at 1000 seconds what was the half-life. So you can go at 1000, you hit the curve and take it to the pressure. Then you multiply that whatever you're going to get in the y-axis with 1 over 2, and that is your half-life. So for a first order process, so we have different formulas for the half-life. So for a first order process, set that is the concentration of A equal to 0.5, the concentration of A at some initial time in integrated rate law. For a first order reaction, this is the formula that we use. It is simply 0.693 over K. That is equal to the half-life. So you don't have to integrate all this, just know this formula. Just know that if you find the rate constant, which is constant K, and you divide it by 0.693, then you have found the half-life. So if you have not been given the constant K, just calculate it, divide it by that number. That is the half-life for first order. For a second order, that is the formula there in pink. It is just 1 over constant K, the concentration of A at some initial time. So whenever you have the constant K and the first concentration, just multiply the constant K by the concentration, then divide by 1. That is your half-life for second order. So they will specify to you that what you're dealing with is second order. Just know how to use the formulas. But of course, in my next video, I'm going to be calculating practice questions. Okay, so this is just an outline that is trying to summarize everything. So rate is equal to that negative K, the concentration of A. That is for first order. So for second order, rate is equal to negative K, concentration of A to the power 2. Or second order can be written as a rate is equal to negative K, concentration of A multiplied by the concentration of B. It's a second order because if you the exponent 1, if you add it with the exponent 1 of B, it will be 2. So second order. Then integrated rate laws for first order is this formula there. Then of course second order it's here. Just know these formulas. They're very simple, especially if you practice them. For the half-life first order, we have this one, and I showed you how to find. Second order, we have this one. So for now, we'll end here till I show you how to practice some questions on this so that you get to be better. Don't forget to subscribe and share to others as well. Thank you so much.